Welcome back. Basic numerical skills. Under this subject, we were dealing with theory of equations, and we dealt with what is meant by theory of equation, different cases of theory of equations, what are the various kinds of equations, different cases, simultaneous equations of first degree in two unknowns, simultaneous equations of first degree in three unknowns, various cases, quadratic equation, how a quadratic equation works, how we can substitute the quadratic equation values to a quadratic formula, different cases. Next, simultaneous equations of two unknown when one is quadratic and other is linear. In the previous sessions, we have learned about linear equations and quadratic equations, but in this section, we are going to deal both the cases in one. In one means in one question or in one case. For example, here x minus y, solve x minus y equal to 2. We all know how to deal with. And at the same time, you are given 2x square plus 5y square equal to 23. It's a quadratic equation. In the earlier cases, we were discussing about solving equations to find out unknown values. In linear equations, you will get two linear equations. There will be two unknowns or three unknowns, and the equations are similar. If you are given two equations, the two equations will be linear. If there are three unknowns, the three equations will be linear. And in the quadratic case, the question will deal only with the quadratic formula or quadratic equation forms. But in this case, you will get a question or case which consists of both linear as well as quadratic. Then how we are going to deal with the situation? Whenever these cases come, just assume the first equation be A and second equation be B. We will substitute the A in B. That's how we are going to deal these type of cases. Before substituting, we need to make necessary changes in linear equation or in equation A. It was given that x minus y equal to 2. Now you have to convert it into x equal to 2 plus y equal to 1. The purpose is we are going to substitute the A in B. So let's take A like this, x equal to 2 plus y, let it be equation 1. Now substitute the equation 1 in B, equation 1. This is what equation 1, equation 1 in B. Then it will be 2 into 2 plus y the whole square plus 5y square equal to 23. Now we have only one unknown. It's going to change into a quadratic form. So we did this step in order to arrive at a quadratic form. Then only we can solve a problem. So next step, how we are going to deal from here. First of all, let's go for brackets. But in bracket, there is one issue. Here it is 2 plus y the whole square. It's in a mathematic formula case. See, 2 plus y the whole square is a case of a plus b the whole square. Whenever you get a case of a plus b the whole square, you have to convert or you have to use the equation a square plus 2ab plus b square. In that case, the equation will be 2 plus y the whole square is 4 plus 4y plus y square. So in this case, you have to split 2 plus y the whole square into in this form. So you will get 2 into 4 plus 4y plus y square plus 5y square minus 23 equal to 0. Now you can go for the brackets. Let's open the bracket and you will get 8 plus 8y plus 2y square plus 5y square minus 23 equal to 0. Next, we will convert the similar values into one single value. Then you will get 7y square plus 8y minus 15 equal to 0. Now it's in a quadratic form. And we can substitute the value of a, b, c from these equations. Then here equation, by using the quadratic formula, you will arrive at two values or two answers. We have discussed about that part in the previous sessions. Y is 1 and minus 15 by 7. Now we substitute the value of y because the question was to solve and find the value of x and y. Now we got y with two values 1 and minus 15 by 7. Now substitute the value of y. Substitute the value of y in the first equation. Then you will get the value of x. Here we have y two values 1 and minus 15 by 7. So in the first case x equal to 2 plus y, that is 2 plus 1, you will get 3. And in the second case you use this one, x equal to 2 plus minus 15 by 7, and you will get minus 1 by 7. Thus the solution for the case is x equal to 3 and minus 1 by 7 and y equal to 1 and minus 15 by 7. We solved this case using quadratic formula or quadratic equation. That's why we got two answers for one unknown variable. That's how you are going to deal with equations consisting of two unknowns when one is quadratic and other is linear. Let's go to some other cases. Solve x plus y equal to 12, x plus x square plus y square equal to 74. The same case which we have discussed in the previous slide. Here x plus y equal to 12. Let's take y equal to 12 minus x. You can choose whatever variable you like. In the previous question I selected x. In this question I selected y. It's up to your discretion. Then substitute the equation 1, this equation in b. Then it will get x square plus 12 minus x the whole square equal to 74. Here now you got a minus b the whole square situation. You have to expand that equation. Then you will get x square plus 144 minus 24x plus x square equal to 74. And you have to change it to a quadratic form by substituting the relevant factors to the respective positions. 2x square minus 2x plus 70 equal to 0. Now it's in a quadratic form. By applying quadratic equations, you will arrive at x equal to 5 and 7 and substitute the value of x, that is 5 and 7, in any equation 1. In equation 1, then you will get y equal to 7 and 5. Next case, x plus y equal to 5, xy equal to 6. How we are going to deal with this situation? Here both are in linear equation format. In the earlier versions you will have either one of the equation will be in quadratic form. Sometimes the equation may not be in, both equations may not be in quadratic form. You have to convert it to some other forms. Anyway, you need to arrive at an answer covering the unknown variables. Here for example, x plus y equal to 5, xy equal to 6. I think we have dealt with this situation or similar situations in application level questions regarding the question related to demand and supply situations. Just refer to that slide. For the time being, let's go to this area. Let's take x plus y equal to 5, where x equal to 5 minus y equal to 5 minus y. Let us assume that equation be C and substitute the equation C, or x equal to 5 minus y in the equation B. Then you will get 5 minus y into y equal to 6. That is 5y minus y square minus 6 equal to 0. You have to make necessary changes in the values so as to arrive at a quadratic form. Now you received y square minus 5y plus 6 equal to 0. By using the quadratic equation, you will arrive at answer y equal to 3 and 2 and substitute the values of y, that is 3 and 2, in equation C or any of the cases, and you will arrive at x equal to 2 and 3. That's all for today. We will deal with further cases in the next module. Thank you.